Today's topic is about solving systems of equations by using substitution. So there are different ways to solve systems of equations, and we're going to go through those different ways. But our first way is through substitution. Now, the end point, the end game for all of these, for solving for systems, is that your answer is going to be a point. It's going to be x, y, and you're solving for both x and y point. Okay, so really what systems are is that there are two lines that cross, and where they cross is going to be your answer. All right, but we're going to focus on the basics of solving for x and y with systems. Okay, so let's get to an example. So really, well, first let me just show you a basic example. Really what you're going to have is you're going to have an x plus y equals some number, right? We're just going to put a question mark. X plus y equals, some number, okay? And so the point is that you need to find what x equals and what y equals, okay? And that's what we're trying to do here. It's trying to solve for both x and y, and it's going to be a point of whatever is going to be, okay? So let's go with a few examples now. X plus y equals 10, y equals 4x. Okay, so we have two equations. Okay, now this is one whole problem, but there's two separate equations we have on here. Okay, so we have our first one, which is x plus y equals 10, our second one, which is y equals 4x. Now remember, the whole point of this, the key word, is substitution. So we're going to use we're going to be substituting terms together. Okay, so what does this all mean? Okay, well, let's look at our equation. Remember, our endpoint is to have an answer x and y. That's our endpoint. Okay, so let's take a look. X plus y equals 10, y equals 4x. So y is here by itself. Okay, y equals this 4x. We know that y equals 4x, but unfortunately, when we get y by itself, it has to be just a number. We can't have any letters involved with it. Okay, so if we know that y equals 4x, we can take this 4x and we can plug it in for the y in this problem up here. Okay, so this is the same. These are both the same problem. Okay, it's not that there's two different equations, but there's the same problem. Okay, so if we have y equals 4x, this 4x can be substituted for the y in this problem. And if we write our new problem, we have x plus, and instead of y, we're going to write 4x, and that equals 10. Okay, so we have our original equation here. We substitute our 4x because y equals 4x. We can take that, plug it into our y in this equation, and have x plus 4x equals 10. Okay, now when you're here, you can go ahead and solve for x, because now you have x here. Okay, now it's just a two-step equation, right? So we gotta get x by itself. So how do we do that? Well, the first thing we do is combine our like terms. So we have x plus 4x, and we know that equals 5x. Bring down the rest. Now we know it's 5x equals 10. Our last step here, we divide, because this 5 is attached to the x. We divide both sides by 5. That cancels, and x equals 10 divided by 5, which is 2. So x equals 2. Okay, so if we go up to our problem here, x equals 2. Now we need to solve for the y. Okay, now how do we do that? Well, we take what we got for our x, and we're going to plug it back in to one of our equations here and solve for the y. Now if you look, the easier equation is the second one, because the y is already by itself, and it's 4x. Remember, if it's the number is attached to a letter, you're multiplying 4 times x. So if x equals 2, we can take our 2 and plug it in for our x in this problem. Now we can do this. Y equals, and instead of 4x, we can do 4 and then parentheses 2. Okay, so all I'm doing is taking this x equals 2, because x is 2. I can plug 2 in for the x here, substitute it, just switch it out, and write our new equation, 4 times 2. And when we do 4 times 2, we get 8. So our y is 8. So our final answer is 2, 8. x is 2, y is 8. That's our final answer, okay? So that's our end game. It's trying to find this point here, okay? So it can be a little confusing. It can be, there's several steps involved, okay? But once you understand what you're doing, what you're solving for, it gets easier, all right? Now, we know x is 2, y is 8. We know that because if we take these answers, all right, let's erase all this, right? Okay. Now, if we take this, the point is that you can plug in x and y here into these two equations and it works. So for example, if we plug in 2 and 8 here, x and y, if x is 2 and y is 8, we know 2 plus 8 equals 10. That checks out, okay? Same thing here. If y is 8 and 4 and then x is 2, we know that 4 times 2 is 8 and 8 equals 8, and it also checks out. So we know this is our answer. We know this is the correct answer because you can plug it into both equations and they both check out, okay? Breathe with me. It's gonna be okay. All right. So that's our first example, okay? Now you don't have to check it every time. I'm just showing you how it works out and how we get to that point, okay? So let's try a different problem. 2x plus y equals 13. X equals 6y, okay? So same thing, solving for x and y, trying to get our point here, okay? Now, in this equation, we have 2x plus y equals 13 and x equals xy. So let's look, what letter is already by itself? Well, x is already by itself here, and x equals 6y. So like we did in the previous problem, we can take our term here and plug it in for our x. So if we take our 6y, we can plug it in to the x, okay? We're just gonna take it, we're gonna substitute the x with our 6y. So when we rewrite our new problem, we're gonna have 2, and instead of x, it's gonna be parentheses 6y. Now use parentheses when you're plugging anything in or substituting anything, using the parentheses to show that's what we're doing, okay? And then we're multiplying, okay? So 2 and x is no more, x is now 6y, and then write the rest of the problem, plus y equals 13, okay? So it's the same problem, but our x is now 6y, okay? Now we have 2 y's in here, now we can solve for y, okay? So let's do the math. Get rid of these parentheses first. 2 times 6y. So remember, you can multiply. You can multiply on like terms, right? You can multiply and divide them. You just can't add or subtract them. So let's multiply. 2 times 6y. 2 times 6 is 12, and then the y stays attached to it. Bring down the rest of the problem. 12y plus y equals 13. Okay. Now combine like terms. 12y plus y. We know that equals 13y. Bring down the rest of the problem. Now our last step, 13y equals 13. We divide on both sides. Okay. 13 cancels out there, and y equals 13 divided by 13, which equals 1. Okay. So our y in this problem is 1. Okay, that's our y. Our y is 1. Now we know y. We can plug it back in to an original equation and solve for x. Now, like the last problem, x is already by itself here. So let's do it the easy way. We can take our y, our 1, and plug it in to our y right here, and substitute this y for 1, or this y. So now our new problem was going to be x equals 6 instead of y. We're going to put a 1. Okay. Now we know that 6 times 1 equals 6. So x equals 6. And that's our answer. So our final answer, x equals 6. Okay, so it seems like it's complicated. It seems like a long process, but the more you do it, the better at that you're gonna get. Okay. So let's try a different problem. y equals 2x, 3x plus 3y equals negative 18, okay? So now we have this equation here, right? So once again, we know out of our two, we look for the one that's easier to figure out, okay? We know that our y is by ourselves here, so y equals 2x. So we can take our 2x, all right, we can take this, and because it's y, we plug it in for the y, okay? The point is that we need to solve this equation. Remember, you can't just do 3x plus 3y because they're not like terms, right? This has an x, that has a y. You can't do that. That's why we need to substitute this for the y here and substitute it with the x in it to make it work, okay? So let's rewrite our problem, okay? So 3x, that stays the same, plus 3, and instead of the y, we're going to use, in parentheses, a 2x, and then that equals negative 18. So, once again, same equation as we did above, but instead of a y, I'm plugging the 2x in for it because y is they're the same. 2x is y is 2x, okay? So 2x goes in for the y, and that's how we get here, okay? Now, we solve for x, finish the problem. What do we do first? Well, multiplication first, right? Get the parentheses out of the way. So 3 times, so let's bring down, this 3x, we're not doing anything with it. We can bring that down. 3 times 2x. What is 3 times 2? It's 6. X stays attached. Bring down the rest of the problem. Combine like terms. 3x plus 6x. When you add them is 9x. Bring down the rest of the problem. Last step, what do we do here? Divide. Divide by 9 on both sides. That cancels out. And x equals negative 18 divided by 9, which equals negative 2. Okay. So that's our x. So x equals negative 2. Okay. Now, you don't have to write this up here, Sean. I'm just showing you how we're doing it. Okay. So x is negative 2. Okay. Now, once again, we can take our x, plug it in to our original equation. So our negative 2, okay, our negative 2 comes up into our 2x here. Okay. Now, we have y equals 2, and instead of x, remember our x is now negative 2. So we can do times negative 2. Okay. So now, when we solve, y equals 2 times negative 2, which is negative 4. And that's going to be our final answer. Negative 2, negative 4, xy. Okay? That's our final answer. Okay? Let's do another one. Two x minus 3y equals negative 1. Y equals x minus 1. Okay, so now we get a little more, add a few more elements to it, right? Now, we still have our y by itself here, right? But instead of it being like a 2x or a 5x or whatever, now it's x minus 1. So we can still use substitution for this, okay? We can still plug this into our original equation, okay? So y equals x minus 1, okay? So this whole x minus 1, because it equals y, we can plug it in to the y in the problem above it, okay? If we rewrite our equation, we have 2x minus 3, and instead of it being a y, it's going to be, in parentheses, our problem here, x minus 1. Okay? So now we have 2x minus 3 times x minus 1 equals negative 1. Okay, now we can solve for x in this equation here. So, what's our first step for solving for x? Well, we have to get rid of the parentheses here. Okay, and now we have x minus 1. We can't do anything with that, so we have to distribute our 3. So we take our 3, we distribute it in, and multiply by everything that's on the inside of the parentheses. So our 2x out here, we can bring this down. Now look, we have a minus in front of the 3, So this makes us a negative 3. So negative 3 times x gives us negative 3x. And then negative 3 times negative 1 gives us a positive 3. And then we can bring down that negative 1. Okay, so all I did was distribute. Negative 3 times x, negative 3x. Negative 3 times negative 1, positive 3. Now, what do we do next? Well, we have like terms. We combine our like terms. 2x minus 3x. When we do that, 2 minus 3 is negative 1x. Bring down the rest of the problem. Okay. Now, to get x by itself, we have to move this 3. It's a positive 3, so to get rid of a positive 3, we do the opposite. Minus 3 here, minus 3 here. That cancels out. Bring down your negative 1x, and that equals negative 1 minus 3. Negative 1 and negative 3, when you do that math, you get negative 4. Last step, divide by negative 1 on both sides, and that cancels, and x equals negative 4 divided by negative 1, which is a positive 4. Okay, so our x equals 4. We can plug that in here. X equals 4. Now we need to figure out our y. So, once again, look at your original problems. We have 2. Pick the one that's easier to work with. This one, because our y is already by itself. So, we take our answer. X is 4. Plug it back in to the x in this problem here. Okay? So now a new problem is going to be y equals, instead of x, we're going to use our 4. So y equals 4 minus 1. Okay, same problem, right? But instead of x, we found our x. Our x is 4. So we take our 4, plug it into the x, and we get 4 minus 1. And we know that 4 minus 1, when we do it, is 3. So our final answer is 4, 3. Okay, x and y, 4, 3. Okay. So this will be part 1 of solving for systems by substitution. Go to part 2 to finish up.